Hello. I'm Dr. SAP, and I'm thrilled to continue our journey together. I hope you're doing well. Today, we're starting a brand new chapter focused on master data in production. Master data forms the foundation for efficient production processes in SAP, connecting raw materials, work centers, and operations to create a robust framework for planning and execution. To make things easier, let's imagine we're managing a bakery. Our goal is to organize the entire process of producing cakes, from basic recipes to more elaborate creations. Get ready. We're going to explore how master data can structure these processes seamlessly. Let's start with the bill of materials, BOM, which defines the components required to produce a product. Imagine we're making a basic cake. The BOM for this cake would include the following ingredients. First, we add flour, which provides the structure for the cake. Next, we include eggs, which bind the mixture together. Then we add milk, giving the cake its softness and moisture. Finally, we add sugar to sweeten the recipe. With these 4 ingredients, we've created a simple BOM for our basic cake, which will be the finished product in this initial scenario. This BOM organizes the ingredients and ensures that we have everything needed for production. Now, imagine that our bakery business is growing, and we've decided to offer cakes with additional toppings like chocolate, strawberry, and vanilla. In this new scenario, the basic cake, which was previously a finished product, now becomes a semi-finished product. It will serve as the base for creating new finished products. Let's structure the BOMs for these new products. For the chocolate-topped cake, the BOM includes the semi-finished basic cake and the chocolate topping as an additional component. For the strawberry-topped cake, we also use the semi-finished basic cake as the base and add the strawberry topping. And for the vanilla-topped cake, we again use the basic cake and add the vanilla topping. This creates a multi-level BOM structure. The semi-finished basic cake becomes a component within the BOMs of the finished products. This setup allows SAP to efficiently manage dependent requirements planning and cost calculations. For example, when planning the production of the chocolate-topped cake, SAP will review its BOM, identify the semi-finished basic cake as a component, and automatically explode the BOM of the basic cake to ensure all required ingredients are accounted for. With the BOMs defined, the next step is to determine where the operations will take place. These locations are called work centers. Work centers represent the physical or logical facilities where specific production activities occur. They store essential details, such as capacity, the number of operations that can be performed simultaneously. Cost, the cost associated with performing tasks at the location. Activity types, the types of tasks the work center can perform, such as labor, machine usage, or setup time. In our bakery, we can configure 2 primary work centers. Main kitchen, where the basic cake, semi-finished product is prepared. Topping station, where toppings are applied to the cakes. These work centers will be referenced in the routing, which organizes operations and links them to the appropriate locations. Now that we've defined the BOMs and work centers, let's move on to setting up the production routing. The routing will guide us through the steps needed to transform our ingredients into the final product. It connects each operation to a specific work center and defines the time required for each task. Let's take it step by step and see how this comes together. Operation 10. Prepare the kitchen. Our first step is to get the kitchen ready for production. This includes tasks like cleaning the workspace, organizing tools, and ensuring all materials are properly set up for smooth operations. This preparation happens in the main kitchen work center, which is specifically designed for this type of activity. Operation 20. Mix the ingredients. Once the kitchen is ready, we move on to mixing the ingredients. For this step, we'll combine flour, eggs, milk, and sugar into a smooth batter for the cake. This is where precision and consistency are key. This task is also performed in the main kitchen work center, using a mixer. By the end of this step, the batter will be ready for the next operation. Operation 30. Bake the cake. Finally, we move to baking. In this step, the batter is poured into a pan and placed in the oven, where it will bake until it's golden and fluffy. This baking process takes place in the main kitchen work center. By the end of this step, we'll have our semi-finished product, the basic cake, ready to cool and move to the next stage if required. Now that we've defined the routing for the semi-finished product, our basic cake, let's move on to the production routing for one of our finished products, the chocolate-topped cake, a delightful addition to our lineup. This routing outlines the steps needed to transform the semi-finished product into a fully finished product, ready for sale. Each step is connected to a specific work center and includes the standard time required to complete it. Let's walk through the process step by step. Operation 10. Retrieve the basic cake from inventory. The first step involves retrieving the semi-finished basic cake from our inventory and preparing it for the next stage. Imagine this as setting the stage for production. Everything needs to be in place for a smooth operation. This step occurs at the topping station, and we've assigned a standard time of 5 minutes to complete it efficiently. Operation 20. Apply the chocolate topping. Next, we move to the most transformative step, applying the chocolate topping. At the topping station, the semi-finished cake is carefully topped with a rich layer of chocolate, ensuring both its appearance and flavor are perfect. This step demands precision and care, which is why we've set a standard time of 10 minutes for it. Operation 30. Inspect and package the cake. In the final step, the finished product is thoroughly inspected to ensure it meets our quality standards. Any imperfections are corrected, and once the cake passes inspection, it's carefully packaged at the packaging station to maintain freshness and presentation for delivery. This final step takes about 5 minutes to complete. With these 3 steps, we've successfully transformed the basic cake into the chocolate-topped cake, a finished product ready for our customers. Now that we've explored how to define the bill of materials, BOM, work centers, and routing, let's take a moment to step back and think about the broader applications of these concepts. If you use a bit of imagination, you can begin to visualize how these foundational elements of production planning could be applied to the specific products or processes in your own business. Consider how you might structure the BOM for a product you're familiar with. What raw materials or components would you need? What operations are required to transform them into the final product? Where would these operations take place? By extrapolating this example to your real-world scenarios, you can start to see the versatility of these tools in SAP. With these concepts, you can model anything from simple workflows to highly complex production systems. For this course, we'll work with a simplified production process. Our example includes 2 raw materials that have already been procured and are available in inventory. 1 finished product that will result from combining these raw materials. A single operation to streamline the routing and keep things clear. While the process is intentionally straightforward, it will give us a practical understanding of how to integrate BOM, work centers, and routing within SAP. Once you understand these principles, you'll be well equipped to apply them to more complex scenarios. Now, let's transition to the SAP Fiori system to see how this comes together. On this main screen, we'll explore the apps and features that will help us define and analyze production data. The applications here are tailored to meet specific business needs, and any missing functionality can usually be found using the search bar. In this session, we'll begin by defining the bill of materials, BOM, for our finished product. Let's dive in and bring our production process to life. We begin by accessing the Plan to Produce processing menu. This menu serves as the starting point for our production process. Among the options available, we select Maintain Bill of Material to create a bill of materials, or BOM, for the finished product. This step is essential as it defines the structure of the product and its required components. In the next screen, we are in the Maintain Bill of Material interface. At the top, there are filters that allow searching and maintaining existing BOMs, such as material, plant, or BOM usage. However, for this exercise, we will create a new BOM from scratch. To proceed, we simply select the Create BOM button. Next, a pop-up window appears for us to input the main details of the BOM. We start by filling out the material code, which identifies the finished product. Then we select the BOM usage, specifying how this BOM will be used, such as for production or costing purposes. It is important to note that BOM usage determines the context in which the BOM will be applied in various business processes. Once the mandatory fields are completed, we can move forward by selecting OK. Now we arrive at the main BOM screen. This is where we define the components of the finished product.
At this stage, we will add the components to the bill of material for the finished product FP001. Each component represents an item that is part of the product structure. Let's start by understanding the fields on this screen. The item category specifies the type of item being added. For our example, we are working with inventory items, which are categorized as stock items, L. This category indicates that the materials are stored in inventory and used during production. Now, we begin by adding the first component. In the component field, we input raw 001, representing a raw material required for the finished product. Next, we enter the quantity as 1 to specify how much of this material is used in the production of 1 unit of the finished product. We repeat the process for the second component. In the component field, we input raw 002, and for the quantity, we again specify 1. Once all components are added, we review the details to ensure accuracy. Finally, we select Create to save the bill of material and complete this step in the process. With the components successfully added and all details reviewed, the bill of material for the finished product FP001 is now complete. This BOM will serve as a foundation for production planning, ensuring that the necessary materials are identified and accounted for. With this step, we finalize the structured BOM for our product, setting the stage for future manufacturing processes. To create a routing for our production process, we begin by navigating to the Plan to Produce Processing section. Within this section, we select the Create Routing tile, where the configuration of the routing process is initiated. On the initial screen, several key fields are visible, such as material, plant, and key date. The material field specifies the product we are configuring the routing for. In this case, we use FP001 as our example. The plant field identifies the manufacturing location, set to 1010. The key date indicates the validity period of the routing, ensuring it applies to processes beginning on or after this date. Moving forward, the next screen leads us to the header details, where we define the overarching structure of the routing. Here, the group counter is set to 1, uniquely identifying this routing for the specified material and plant. The usage field determines how the routing will be applied. In this scenario, the usage is set to production, aligning with our goal of facilitating the manufacturing process. Additionally, the overall status is defined as Released, General, indicating that the routing is finalized and ready for use in production planning. This status confirms that the routing is active and requires no further approvals. We then specify the lot size, ensuring this routing applies to production volumes ranging from 1 to 100 units. This step is crucial to ensure proper alignment between the routing and the expected production quantities. Once all details for the routing header are reviewed and confirmed, we proceed to the next step by selecting operations from the menu at the top. In this phase, we will define the specific tasks or operations that form part of this routing. These operations will be linked to a work center, enabling accurate allocation of resources and efficient production planning. Now, let's move forward by configuring the operations in our routing. Here, we're setting up just one operation as an example. First, we enter the work center as WC001. A work center represents a specific location in production where tasks are performed, such as a machine or a manual station. It's also important for capacity planning, scheduling, and costing purposes. Next, we define the control key as YBP3. This key determines how the operation will be handled in terms of costing, capacity requirements, and process tracking. It's a crucial element to ensure the operation functions correctly within the production process. We then provide a description for the operation, specifying the task it represents, keeping this simple for our current example. To dive into the operations details, we double-click on operation 0010. Here we define the machine time as 60 minutes, equivalent to 1 hour, and the labor time also as 60 minutes. These times apply to the production of one piece. If the production quantity increases, these values will scale proportionally based on the lot size, ensuring precise calculations for larger production runs. Once the time details are set, we click on the Work Center icon at the top to access its configuration. As we continue exploring the Basic Data tab, we observe the core details of this work center, including the category, responsible person, and usage. Here, the work center is categorized as machine, and it's linked to usage type 009, which applies to all task list types. Using the scroll bar, we review additional fields related to general information, ensuring that all necessary details are captured. In this tab, we also highlight the standard value maintenance section, which plays a crucial role in defining performance measurements for operations. The standard value key, set to SAP 1 for normal production, determines the standard values applicable to operations, such as setup time, machine time, and labor time. These values are critical for accurate scheduling, capacity planning, and cost calculations. Below, the standard values overview provides a detailed breakdown of these metrics. For example, setup, machine, and labor activities are defined here, and the column rule for maintenance specifies whether any checks are enforced, showing no checking in this case, allowing flexibility in data entry when adjustments are needed. Using the scroll bar, we ensure all fields are visible and correctly configured before moving to the next tab. Next, we navigate to the Default Values tab, which defines the control key and other default operational settings. This tab simplifies the operation setup by predefining key attributes for tasks carried out in this work center. We ensure these fields are configured accurately to reflect the operational standards. Shifting to the Capacities tab, we focus on the capacity-related configurations. This section is vital for planning and scheduling as it sets the default capacity and defines formulas for processing and setup times. These configurations ensure the work center's availability and load can be calculated effectively for production planning. Then, we move to the Scheduling tab. This section highlights the scheduling basis, execution times, and interoperation times. For instance, the setup and machine processing times are defined here, enabling precise scheduling of tasks within this work center. Following this, we explore the Costing tab, which is essential for financial planning. This tab links the work center to a cost center, in this case, CC001, predefined by the controlling department. The Activities Overview displays the labor and machine rates, set at €20 per hour and €10 per hour respectively. These values are used in both standard cost calculations and production order cost planning. After reviewing all these tabs, we return step by step, first to the Operation Details screen and then to the Operation Overview. With all configurations verified, we complete the process by saving the routing, which is now ready for use in production planning. This routing serves as a crucial element for cost determination, capacity planning, and operational efficiency.
Great job today, everyone. Let's take a moment to recap what we've accomplished in this session. We started by working with the Bill of Materials, BOM, which serves as the foundation for defining the components required for manufacturing a product. We carefully examined how to structure the BOM, ensuring it reflects all necessary materials and quantities for production. This step set the stage for connecting the materials to the production process. Building on the BOM, we moved into the creation of a routing, which outlines the sequence of operations needed to produce the final product. We defined key elements such as operations, control keys, and work centers, ensuring every step aligns with the material and plant requirements. Along the way, we saw how routings link to cost centers, providing visibility into labor and machine costs. We also delved into the work center configuration, where we explored key tabs like basic data, default values, capacities, scheduling, and costing. Each tab plays a unique role in optimizing production planning. For instance, the standard value key helps define setup, machine, and labor times, which are crucial for accurate scheduling and resource allocation. Finally, we tied everything together in the operation overview, confirming that all configurations, from the BOM to routings and work centers, align seamlessly to support production planning and cost management. By linking BOMs, work centers, routings, and cost centers, we've established a comprehensive framework for efficient and accurate production processes. These steps are essential for ensuring operational success and financial precision. Well done. With this knowledge, you're well prepared to navigate production planning in SAP. Keep up the great work, and I'll see you in the next session.